Today I will solve two examples related to similar triangles. Okay, as you can see this problem. Calculate the height of the chart, a very tall building in London using similar triangles. So as you can see in the figure, I want to calculate that blue height. Let's name it H, for example, okay, using similar triangles. Okay, similar triangles. I just want you to, if you cannot get it like this, you can cut these triangles. Like this is the small triangle here. So I have two dimensions, 3 and 2, and the bigger triangle, which is H, as you can see. Take care because the base here is all of this distance, which will be 459 plus 3. So it will be 462. Okay, now I can apply the proportion for the similarity. I prefer to write the h on the top. So h over 2. I'm writing the corresponding sides. H over 2 equals to 462 over 3. Okay. And then easily you can use the cross multiplication to get the h. You can do it mentally. You can use the calculator. It's up to you. H will be equals to 2 times 462 over 3. If you simplify it, the height will be 308. Okay, so it depends on, you have to write the proportion correct. Like here, the 2 and the H. Okay, these are the two bases, the small and the bigger one. And then the 3 corresponding with this 3, I cut the two triangles like this over all of this, which is 462. The main thing that you have to write the proportion in a correct way. Okay, this is the first problem. Okay, I have another problem. Here it involves parallel lines as well, but it's a common problem. Okay, I have two parts for this problem. The first says show that the triangle PQR and triangle RST are similar. In order to prove similarity, either you will get the three angles inside the triangle equals to the other three angles of the other triangle, or you get proportional sides. Here I don't have proportional sides. I have only 4 in this triangle, 8 in this triangle. I have 5 in the first triangle, and X, so I don't have a lot of numbers. But this parallel, I can use it for the angles. Remember the last video I said if you have these two arrows, it means the two lines are parallel. Start to think about alternate interior angles or corresponding angles or whatever interior angles. But here I am concerned about the alternate angles. Can you see the Z? Okay, and here these are alternate angles. So these two angles are the same. Let's name it, for example, this is angle A, this is angle A. Okay, and the same for angle QPR, which is this. Let's name it B, or any letter. That will be equals to angle RTS, which is this. I'm just naming it the same letter because I will need this now. Okay, the third angle, of course, it will be equal. Let's name it C because they are vertically opposite angles, like the X. Okay, okay. This is the first part of the problem because three angles, angle A in the upper triangle equals to angle A in the other triangle, the bigger triangle, angle B equals angle B, C equals C. So I have three angles equals to other three angles in a different triangle. So these two triangles are similar. That's number A. For number B, I want to find the missing length. Take care while choosing the numbers and the proportion. I want to do something, a proportion like this, but I have to arrange the number correct. So I prefer to add like the x in the numerator, x this side. Take care, the corresponding side for x in this triangle will be 5. Why it's 5? Because here the x is between the angle A and angle B. And the 5 is between angle A and angle B as well. So x is corresponding to 5. When you start the numerator by the bigger triangle, I have to start the second proportion by the bigger triangle as well. So I have to add the 8 in the numerator, and the denominator will be 4. Why did I choose 8 and 4? Not because they are the only numbers, but because 8 is between angle C and B, and 4 is between angle C and B as well. Here you can get the x directly by using the cross multiply, or you don't need even to use the cross multiply, because 8 is double 4, so the x will be double 5, will be 10 directly. So here I got the x. I hope that it's clear now.